Hello guys, I am your Dinesh. Today we are starting a new chapter, that is polynomials. This is chapter 2 of your NCERT textbook of class 10. So my lectures are going to be relevant to all CBSE students across the nation and also those state syllabus students who follow NCERT textbook. And my teaching is will be based on NCERT textbooks. So we are starting a chapter polynomials. This chapter is quite interesting guys and easy as well. It's not so tough. There might be some concepts which are tough. I'll make sure that I'll make it easy for you guys. And this chapter is not just important for this class but also for your future classes. In your higher classes, these concepts which you learn here are going to be used. So it's very important that you master this chapter well here itself. So first let's see the meaning of the word polynomial guys. Polynomial is made up of two words, poly and nomial. Poly means many and nomial means terms. So polynomial means many terms joined together with the operations like plus and minus. This is one term guys. 2x square is one term. 7x is one term. And 11, the number 11 is one term. 2x is one term. 3x square is one term guys. When these terms are joined with operations like plus and minus, this whole expression becomes a polynomial expression. Now for example, x cube plus 3x plus 8 is also a polynomial. X square plus 8x is also a polynomial. These are the examples of polynomials. Now before going further into the chapter, let's first see the difference between an algebraic expression and a polynomial guys. This difference is not given in your NCERT textbook, but I felt like it's important for you people to know this difference. Because many people learn polynomial but they won't know the difference between algebraic expression and polynomial because they both look quite similar, right? So now I'll tell you the difference between algebraic expression and polynomial. This topic is not in your NCERT but even then I wanted to explain you. Algebraic expression, power can be in fraction. In algebraic expressions, powers can be in fraction. For example, 2x to the power 1 by 2. The variable x to the power 1 by 2 is there in this expression. 3x to the power 3 by 4. So the powers of the variable in this expression are in fractions. But the condition for an algebraic expression to be a polynomial is that the powers cannot be in fraction. It should only be natural numbers. Natural numbers in the sense it's like 0, 1, 2, 3, 4 and so on. It can be any natural numbers but it cannot be a fraction. That's the first criteria for algebraic expression to be a polynomial. And the second condition is that power cannot be in negative. For example, x to the power minus 2 plus 3x plus 11. This cannot be a polynomial guys. This can only be an algebraic expression. For algebraic expression to be a polynomial, the expression in the expression term, no variable's power should be in negative. That's the second condition for algebraic expression to be a polynomial. This was the difference guys. It's important to know. Just keep it in your mind. Probably they won't ask in the exams, but still. Now after this, let's go to the classification of polynomial based upon variable of polynomial and degree of polynomial. Now polynomial you can broadly classify into variable of polynomial and degree of polynomial guys. Classification based upon variable of polynomial is whether the polynomial contains, it's based on which variable the polynomial contains. For example, this polynomial, these two polynomial has the variable as x and these two polynomial as the variable as y. So these are polynomials in x variable and these polynomials are polynomials in y variable. So you can classify them on basis of variable of polynomial. And the second type of classification is classification based on degree of polynomial. So now the question is, what is degree of polynomial? Degree is the highest power present in that polynomial. Highest power of the variable present in that polynomial. For example, if this is a polynomial, the highest power present in this variable of polynomial is 1. If there is nothing written, it's 1, right? For example, let's take this polynomial. Now, x square plus 3x minus 2 is the polynomial. The highest power present on the variable of this polynomial is 2. Here it's 1 and here it's 2. The highest power is 2. So the degree of this polynomial is 2 degree. 2 degree polynomial will be called as quadratic polynomial. So this is the difference based on, this is the classification based on powers guys. If it is power 1, if the degree is 1, it's called as linear polynomial. If the power is 2, it will be called as quadratic polynomial. And if the degree is 3, it will be called as a cubic polynomial. These are the general forms of the linear, quadratic and cubic polynomial. Now, after learning what is polynomial and the classification of polynomial, let's go ahead and learn what is zero of a polynomial. So, zero of a polynomial is that number k when replaced in the place of x, p of k equal to 0. So what this sentence means is, guys, zero of a polynomial is that number when you replace that number in place of the variable of that polynomial, that resultant will be equal to 0. For example, guys, let's take this polynomial. So let's try to find the zero of this linear polynomial. To find the zero of this linear polynomial, first you will equate this linear polynomial to equal to 0. Then you will get as 2x equal to minus 3. Then the value of x you will be getting as minus 3 by 2. Now this is the zero of this linear polynomial, which means if you replace this minus 3 by 2 in the place of x, you'll be getting the whole value as equal to 0, guys. Let's cross verify it. So this is our k which we are going to replace. This is the k, guys. So this is the value of that k which we are going to replace in the place of x. So we'll be getting p of k, which will give us 0. Let's verify this, guys. Now in the place of x we'll be writing as minus 3 by 2 plus 3. So 2 gets cancelled. We'll be left out with minus 3 plus 3, which will be equal to 0. Which means minus 3 by 2 is the zero of this polynomial. For a linear polynomial, at most 0 can be only 1. Number of at most zeros of linear polynomial is 1, and the number of at most 0 for a quadratic polynomial is 2, and the number of at most zeros for a cubic polynomial is 3, which means a cubic polynomial can have less than or equal to 3 zeros. After learning how to find the zeros of a linear polynomial algebraically, now let's go ahead and learn how to find the zeros of a linear polynomial graphically. In this chapter, you will learn how to find the zeros of a linear polynomial, quadratic polynomial, a cubic polynomial, both algebraically and graphically. Just now we learned how to find zeros of a linear polynomial algebraically. After few lectures, you will be learning how to find the zeros of a quadratic and cubic polynomial algebraically as well. Now let's understand how to find the zeros of a linear polynomial graphically. So let's take the same linear polynomial which we solved, 2x plus 3. To make it into a graph, you have to equate it to y. Only then you'll be able to make a graph, because graph is made up of two variables, x and y. So you'll need two variables. So we equate it to y equal to 2x plus 3. Now what you have to do is you have to get the points or the coordinates which you'll be able to locate in the graph, and then draw the graph and then draw the curve of this equation. So for that, what we'll do, we'll draw a table and then we'll plot the values of x and y. We'll put the value of x and get the value of y. First we'll put a easy number such as, we'll be putting an easy number such as minus 1, 0, 1, 2, a small number, and we'll try to get the value of y. So when we put the value of x as minus 1, we get the value of y as 1. And then when we put the value of x as 0, we get the value of y as 3. And then when we put the value of x as 1, we get the value of y as 5. So these are the three coordinate points which you have got. To draw a linear graph, which is a line, you require only 2 points. If it is 3, it is okay, but even with 2 kaam chalega. So now we will plot these points in the graph. Minus 1, 1 is here. Minus 1, 1 is here. And then 0, 3 is here. And then 1, 5 is here. When you join all these points together, you will get a line passing through minus 3 by 2. Which means this point, this intercept of the line on x-axis gives us the zero of this polynomial. So what we get to know is the intersection of the line on the x-axis gives us the zero of a polynomial. If it is a quadratic polynomial, we will get something like a parabolic shape which will intercept in the 2 points, which will give us the 2 zeros of the quadratic polynomial. If it's a cubic polynomial, we'll get a graph something like this or something like this, which will cut the x-axis in 3 places, which will give us 3 zeros of a polynomial. In the further chapter, we'll see how to find the zeros of polynomial of quadratic and cubic polynomial.